Hello children, let us solve previous year's JEE questions. Look out for question number 7, that is a tricky one. And last two questions, they are JEE advanced questions. So let us start. First question, consider a force F is equal to minus xi plus yj. The work done by this force in moving a particle from point A 1, 0 to B 0, 1 along the line segment is. All quantities are in SI units. These are the options given and this is figure given. This question was asked in JEE Mains 2020. Given force F is variable in nature. It depends on values of x and y. It can be written as F is equal to Fxi plus Fyj. That is horizontal and vertical components of force F. We know that work done by a force F in moving an object a small distance dr is given by dw is equal to F dot dr. F can be written as Fxi plus Fyj and dr can be written as dxi plus dyj. Dot product of these two vectors will give Fx dx plus Fy dy. That means dw is equal to Fx dx plus Fy dy. Now we can integrate both sides of this equation within limits. We get integration of dw from 0 to w is equal to integration of fx dx from x initial to x final plus integration of fy dy from y initial to y final. It is given that particle is moving from point A to point B. That means x initial is 1, x final is 0, y initial is 0 and y final is 1. Putting lower and upper limits and integrating, we get W is equal to 1 joule. So, correct option is option B. Second question, a small bob tied at one end of a thin string of length 1 meter is describing a vertical circle so that the maximum and minimum tension in the string are in the ratio 5:1. The velocity of the bob at the highest position is dash meter per second. Take g is equal to 10 meter per second square. This question was asked in JEE Mains 2021. Suppose this is bob. It is connected to one end of the string. Other end of the string is fixed at point O. This bob is moving on a vertical circle. It is given that ratio of maximum and minimum tension in the string is 5:1. We know that maximum tension in the string will be at lowest point A and minimum tension in the string will be at topmost point B. Suppose tension in the string at lowest point is T1 and at topmost point is T2. So T1 is to T2 is 5:1, that is given. Suppose velocity of the bob at lowest point is VA and at highest point is VB. We have to calculate the value of VB. At point A, the net force will work towards the center and that is T1 minus mg and that will provide necessary centripetal force, that is mVA square upon L. So T1 is equal to mVA square upon L plus mg. Suppose this is equation number 1. At point B, net force will work towards the center and that is T2 plus mg and that will provide necessary centripetal force and that is mVB square upon L. That gives T2 is equal to mVB square upon L minus mg. Suppose this is equation number 2. Given that T1 by T2 is equal to 5:1. That means mVA square upon L plus mg upon mVB square upon L minus mg is 5:1. Put L is equal to 1 meter. It is given as length of the string is 1 meter. So this gives 5 mVB square minus mVA square is equal to 6 mg. Suppose this is equation number 3. We have to get the value of VB. That means we need one more equation. So we can apply conservation of mechanical energy at point A and B. Suppose our reference line that is horizontal passes through A. So kinetic energy of the bob at point A is half mVA square and potential energy is 0. So at point A, mechanical energy will be half mVA square plus 0. At point B, kinetic energy of the bob will be half mVB square and potential energy will be mg into h. H will be L plus L and that is 2L. So at point B, mechanical energy of the bob will be half mvb square plus 2 mgl. Put L is equal to 1 meter. This gives mva square minus mvb square is equal to 4 mg. Suppose this is equation number 4. We can solve equation number 3 and 4 to get the value of Vb is equal to 5 meter per second. That is our answer. Third question. Two particles A and B are moving on two concentric circles of radii r1 and r2 with equal angular speed omega. At t is equal to 0, their positions and direction of motion is shown in the figure. The relative velocity Va minus Vb at t is equal to pi by 2 omega is given by. These are the options given and this is the figure given. This question was asked in JEE Mains 2019. At t is equal to 0, first particle is at P and second particle is at Q. Both are on the x-axis. Their angular speed is same. That means at any time t, they will make same angle with the positive x-axis. Magnitude of the angle will be same, but sign will be opposite as the particles are moving in opposite directions. First particle is moving anti-clockwise and second particle is moving clockwise. We will figure out at t is equal to pi by 2 omega the angle they will make with the positive x-axis. Omega by definition is equal to delta theta upon delta t, or delta theta is equal to omega into delta t. Delta theta can be written as theta minus 0 and delta t can be written as t minus 0. At t is equal to 0, theta is equal to 0. It is given. So theta is equal to omega into, put t is equal to pi by 2 omega. So theta is equal to pi by 2. That means at t is equal to pi by 2 omega, first particle will be at p dash and second particle will be at q dash. Their velocity vectors are v and vb. They are in the same directions. So we can write velocity vector va is equal to minus omega r1 I and vb is equal to minus omega r2 I. We are using v is equal to r omega. So Va minus Vb is equal to minus R1 omega I minus of minus R2 omega I, and that is R2 minus R1 into omega I. So option D is correct. Fourth question, the potential energy U of a diatomic molecule is a function dependent on R, interatomic distance, as U is equal to alpha by R2 power 10 minus beta by R2 power 5 minus 3, where alpha and beta are positive constants. The equilibrium distance between two atoms will be 2 alpha by beta to power A by B, where A is equal to dash. This question was asked in JEE Mains 2021. Potential energy function is given as U is equal to alpha by R2 power 10 minus beta by R2 power 5 minus 3. Magnitude of conservative force is equal to minus du by dr. We can find out du by dr from here. So F is equal to minus 10 alpha into R2 power minus 11 plus 5 beta into R2 power minus 6. At equilibrium, this force must be equal to 0. That means 10 alpha into R2 power minus 11 minus 5 beta into R2 power minus 6 is equal to 0. On simplification, this gives R is equal to 2 alpha by beta to power 1 by 5. Compare this R with the given R. So we get A is equal to 1 and B is equal to 5. We have to write the value of A. So the answer is 1. Fifth question, a particle is moving along a circular path with a constant speed of 10 meter per second. What is the magnitude of the change in velocity of the particle when it moves through an angle of 60 degree around the center of the circle? These are the options given. This question was asked in JEE Mains 2019. Suppose at t is equal to 0, particle is at A, that is along x-axis. Its velocity is Va. After some time, it reaches B, so that angle BOA is 60 degrees. Its velocity at B is Vb. we have to find out magnitude of vector Vb minus vector Va. It is given that particle is moving with constant speed 10 meter per second. That means magnitude of Va is equal to magnitude of Vb is equal to 10 meter per second. We can write vectors Va and Vb. Vector Va is equal to magnitude of Va, J, and vector Vb is equal to, it can be resolved into two components, horizontal and vertical. So vector Vb is equal to minus magnitude of Vb cos 30 I plus magnitude of Vb sin 30 J. So it can be simplified as Vb is equal to magnitude of Vb upon 2 into minus root 3I plus J. So vector Vb minus vector Va will be equal to magnitude of vector Vb upon 2 into minus root 3I plus j minus magnitude of Va j. Put mod Va is equal to mod Vb is equal to 10. So Vb minus Va can be simplified as minus 5 root 3I minus 5j. Now we will find out the magnitude of Vb minus Va, and that is equal to under root minus 5 root 3 whole square plus minus 5 whole square. So that comes out to be equal to 10 meter per second. So option B is correct. Sixth question, a uniform cable of mass m and length L is placed on a horizontal surface such that its 1 by nth part is hanging below the edge of the surface. To lift the hanging part of the cable up to the surface, the work done should be. These are the options given. This question was asked in JEE Mains 2019. Length of the cable is L and the part which is hanging is 1 by nth of L, and that is L by n. Consider a small part of the cable dx which is at a distance x from the edge of the table. Mass of this small part is given by dm is equal to mass per unit length of the cable into length of this small part. So dm is equal to m by L dx. As the cable is getting pulled up, so potential energy of this part will increase. Increase in potential energy is given by du, and du is equal to dm into g into h, and h is equal to x here. So du is equal to m by L into gx dx. We can integrate both sides of this equation within limits. So integration of du from 0 to u is equal to integration of m by L gx dx from 0 to L by n, as the length of hanging part is L by n. So after integration, we get u is equal to mgl upon 2n square. And this is work done on the cable to pull it up completely on the table. So our answer is mgl upon 2n square. So option B is correct. Seventh question, a body of mass 2 kg is driven by an engine delivering a constant power 1 joule per second. The body starts from rest and moves in a straight line. After 9 seconds, the body has moved a distance in meter dash. This question was asked in JEE Mains 2020. Suppose this is the body that is getting driven by this engine. At t is equal to 0, body was at rest. We have to calculate the distance traveled by the body in 9 seconds. Work done by the engine in 9 seconds is given by the formula W is equal to power into time. Power is constant, which is given as 1 joule per second. Time is 9 seconds. So work done by the engine in 9 seconds is 9 joule. Applying work energy theorem, we get change in kinetic energy of the body is equal to work done by the engine. Change in kinetic energy of the body is final kinetic energy minus initial kinetic energy of the body. Final kinetic energy of the body is half mv square. Initial kinetic energy of the body is 0, as the body was at rest initially. M is given as 2 kg. So V is equal to 3 meter per second. That means initially at t is equal to 0, velocity of the body is 0. At t is equal to 9 seconds, velocity of the body is 3 meter per second. Pause for a moment here. What about the acceleration? If acceleration is constant, then we can apply equations of motion in a straight line to calculate the distance traveled by the body in 9 seconds. If acceleration is not constant, then we cannot apply those equations of motion. We need to change our approach. So let us first figure out whether acceleration is constant or not. We know that power is equal to force into velocity. Force can be written as mass into acceleration. So from here, acceleration is equal to power upon mass into velocity. Power is given as constant. Mass is constant, but velocity is not constant. That means acceleration is varying. So we cannot apply equations of motion in a straight line. We need to change our approach. From here, power is equal to m into. Acceleration can be written as rate of change of velocity, that is dv by dt. So v dv is equal to p upon m into dt. P upon m is constant, as power is given as constant and mass is constant. We can integrate both sides of this equation within limits. So we get integration of v dv from 0 to v is equal to integration of p by m dt from 0 to t. This gives v is equal to under root 2 pt upon m. Now v can be written as dx by dt, rate of change of displacement, and that is equal to under root 2p upon m into root t can be written as t to power 1 by 2. So dx is equal to under root 2p upon m t to power 1 by 2 dt. We can integrate both sides of this equation within limits. So we get integration of dx from 0 to x is equal to integration of root 2p upon m t to power 1 by 2 dt from t is equal to 0 to t is equal to 9. Root 2p by m is constant, as power is given constant 1 joule per second. Mass is constant, that is given as 2 kg. So this gives x is equal to 18 meter. That is our answer. So answer is 18 meters. Eighth question. A block of mass m lying on a smooth horizontal surface is attached to a spring of negligible mass of a spring constant k. The other end of the spring is fixed, as shown in the figure. The block is initially at rest in its equilibrium position. If now the block is pulled with a constant force F, the maximum speed of the block is. These are the options given, and this is the figure given. This question was asked in JEE Mains 2019. Suppose this block is kept on a smooth floor. It is connected to a spring, whose other end is attached to a wall. Now this block is pulled by a horizontal force F, so that it starts moving towards right with some speed. Its speed increases up to a certain extent and then starts decreasing. We have to calculate that maximum speed. When this block is pulled by external force F, spring will be elongated. As a result, spring will apply a force on the block towards left, and that force is equal to minus kx as per Hooke's law. So net force on the block will be F minus kx. Work done by this net force to move the block by a small distance dx is given by dw is equal to F net dot dx. Since force and displacement both are in same direction, so their dot product will give F minus kx into dx. We can integrate both sides of this equation within limits. So we get integration of dw from 0 to w is equal to integration of F minus kx into dx from 0 to x. This gives w is equal to fx minus kx square by 2. Suppose this is equation number 1. We can apply work energy theorem. So change in kinetic energy of the block is equal to work done by the net force on the block. Change in kinetic energy is final kinetic energy minus initial kinetic energy of the block. Final kinetic energy is half mv square. Let's say final velocity of the block is v. Initial kinetic energy of the block is 0, as the block was initially at rest. W is equal to fx minus kx square by 2. This gives v is equal to under root 2 fx minus kx square upon m. Suppose this is equation number 2. For v to be maximum or minimum, dv upon dx should be 0. So finding out dv by dx and equating to 0 gives x is equal to f by k. Put this value of x in equation number 2. That gives V max is equal to F by under root mk. So this is our answer. So option C is correct. Ninth question. A particle of mass m is initially at rest at the origin. It is subjected to a force and starts moving along the x-axis. Its kinetic energy K changes with time as dk by dt is equal to gamma t, where gamma is a positive constant of appropriate dimensions. Which of the following statements is or true? These are the statements given. This question was asked in JEE Advanced 2018. It is given that particle is at origin at t is equal to 0. Also, dk by dt is equal to gamma t. This means dk is equal to gamma t dt. We can integrate both sides of this equation within limits. This gives integration of dk from k initial to k is equal to integration of gamma t dt from 0 to t. This means k minus ki is equal to gamma t square upon 2. K is kinetic energy of the particle at some time t. So it is half mv square. Ki is kinetic energy of the particle at t is equal to 0, and that is 0 because particle is at rest at t is equal to 0. So this gives half mv square is equal to gamma t square upon 2, or v is equal to under root gamma upon m into t. Gamma is given as some positive constant and m is also constant. So v is proportional to t from here. Statement B says the speed of the particle is proportional to time is correct. Again, from this equation, if we do dv by dt, we get under root gamma by m. dv by dt is acceleration of the particle. So acceleration of the particle is equal to under root gamma by m. Force working on the particle is equal to mass into acceleration. So F is equal to under root gamma m. Gamma is constant, m is constant. So force working on the particle is constant. Statement A says the force applied on the particle is constant is also correct. Again, from equation 3, V can be written as dx by dt. So dx by dt is equal to under root gamma by m into t, or dx is equal to under root gamma by m into t dt. We can integrate both sides of this equation within limits. So integration of dx from 0 to x is equal to integration of gamma by m into t dt from 0 to t. This gives x is equal to 1 by 2 under root gamma by m into t square. This part is constant. That means x is proportional to t square. Statement C says the distance of the particle from the origin, that is x, increases linearly with time. This means x is proportional to t. That is incorrect because x is proportional to t square. So this statement is wrong. Let us check statement D. It says the force is conservative. Here force is equal to under root gamma m, which is constant, and we know that work done by a constant force does not depend on the path. So this force is conservative. So this statement also is correct. So correct statements are statement A, B and D. Last question. A student skates up a ramp that makes an angle 30° with the horizontal. He or she starts as shown in the figure at the bottom of the ramp with speed v0 and wants to turn over a semicircular path xyz of radius r, during which he or she reaches a maximum height h at point y from the ground as shown in the figure. Assume that the energy loss is negligible and the force required for this turn at the highest point is provided by his or her weight only. G is the acceleration due to gravity. These are the statements given. We have to figure out which one of them are correct. And this is the figure given. This question was asked in JEE Advanced 2020. Angle of inclination of the ramp is given as 30 degrees. Height of point y is given as h. The student enters this path at point A. Speed of the student at A is given as v0. We can apply conservation of mechanical energy at points A and Y. That means kinetic energy plus potential energy at A is equal to kinetic energy plus potential energy at Y. Suppose we take a horizontal line passing through A as reference. Kinetic energy of the student at A is half mv0 square and potential energy of the student at A is 0 because our reference line is passing through A. Kinetic energy of the student at Y is equal to half mvy square. Suppose Vy is the velocity of the student at point Y. Potential energy of the student at Y is mg into height of point Y, and that is h. This gives v0 square is equal to vy square plus 2gh. Suppose this is equation number 1. At highest point Y, component of weight that is along the ramp is mg sine 30, which will give necessary centripetal force. So mg sine 30 is equal to mvy square upon r. This gives vy square is equal to gr upon 2. Suppose this is equation number 2. We can put the value of vy square in equation number 1 to get v0 square minus 2gh is equal to 1 by 2 gr. Statement A says v0 square minus 2gh is equal to 1 by 2 gr. So statement A is correct. Statement B says v0 square minus 2gh is equal to root 3 by 2 gr. So obviously this is incorrect. Let us check statement C. The centripetal force required at point x and z is 0. A student enters the circular path at point x and leaves at z. We know that in a vertical circle, as the height increases, speed of the particle decreases. So speed of a student at points x and z, which are at the same height, will be more than at y. So centripetal force at points x and z will be more than that at y. So statement C that says the centripetal force required at points x and z is 0 is incorrect. Let us check statement D. The centripetal force required is maximum at points x and z. Since point x is entry point and z is exit point of the circular path, that means speed of the student at points x and z will be maximum. So centripetal force mv square upon r that depends on speed will also be maximum. So statement D is correct. So correct statements are statement A and D. In the next video, we will start chapter number 6, and that is System of Particles and Rotational Motion. If you have a question, you can ask me on my Discord server. If you have not subscribed my channel yet, please do so.